In Chapter 7, we're going to be dealing with exponents. And our first sections that we're going to cover are 7.1 through 7.3, which cover all of the properties of exponents. I cover the lecture portion for all three sections at the same time. That way we get all of the properties out before we start dealing with the exponents. As a review, exponents are repeated multiplication. For example, if I have y times y, I can write it as y squared. Similarly, y times y times y is y cubed. And I am going to use those two to develop our properties of exponents. And the first one is, what if I have y squared times y cubed? Okay, to prevent confusion, what you can do is you can write what y squared is equal to, and that's y times y. Copy that one. And then y cubed is y times y times y. And that is equal to 1, 2, 3, 4, 5 y's, or y. 5 y's multiplied by each other, or y to the fifth. So as a general rule, if you have a number to a power times the same number to another power, all you do is you add the exponents together. So that is our first property of exponents. Next one I want to do is y squared cubed. Notice I have the 2 and the 3 exponents on both of these, and this is so you can see how we're going to come up with the different rules. Well, something cubed means to multiply this by itself 3 times. So that would be y squared times y squared times y squared. And the previous property said that, hey, if I have two things with the same base multiplied with exponents, that I just add the exponents. So 2 plus 2 plus 2 is y to the sixth. Or I could have wrote y, 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 then counted all 6 of them up and got the answer. So the property we have is if I have a base to a power raised to another power, I end up multiplying the exponents together. The next property deals with if I have two separate things raised to a power. Well, what this says to do is take xy times xy. Okay, and multiplication is commutative, so I can write it in any order I want to. So that's xx, yy, which would be x squared, y squared. Okay, this intermediate work that I'm showing on all of these is not required. Once you know what the property is, you can directly use the property. So what this is saying is that if you have a multiplication problem of numbers or variables, the exponent that's outside the parentheses applies to each of the variables. So I'm going to write a, b to the m is equal to a to the m times b to the m. This does not work for addition or subtraction inside the parentheses. It only works for multiplication. So we've done multiplication problems. The next one I'm going to do is a division problem. So I am going to do y cubed over y squared. Well, that's y times y times y over y times y. And if you notice here, that y will cancel that one to be 1. That y will cancel that one to be 1. And that's going to leave me with y. And there is an invisible exponent of a 1 here. So I had 3 on the top, 2 on the bottom. And how do I get 1 out of those? Well, I had 3 and I took away 2 of them, the 2 that were on the bottom. And taking away in math is subtraction. So if I have a to the m over a to the n, I end up with a to the m minus n. Next thing I want to talk about is if I have something to a 0 exponent. Well, a 0 exponent can come from, like, let's do it this way, y squared over y squared. Well, that's y times y over y times y. We know that that is y to the 0th, because I have 2 minus 2, which is 0. But we also know that any number divided by itself, except for 0, is 1. Okay? So here's some things that I want to write down. The first thing we're going to write down is 0 to the 0th is undefined. Some students coming out of middle school think 0 to the 0th is also 1. It's not 1 because that would come from like 0 squared over 0 squared, and we're not allowed to divide by 0. And a to the 0 is equal to 1, where a is not equal to 0. So those are the first 6 properties. I'm going to pause and erase this work that I did for the first 6 properties. I'm going to leave these properties up here, and then I'm going to do the last properties, and then we're going to do some example problems. The next thing I'm going to do is I'm going to talk about if I have something like this, 1 over y squared. Okay? Well, I know 1 is actually y to the 0th. So I have like y to the 0th over y squared. And I know if I have a division problem that I take the top number minus the bottom number. So 0 minus 2 would be y to the negative 2. Okay, in general, the property states that if I have 1 over a number to a power, that is the same thing as the number to the negative power. Similarly, if I have a number 1 over a number to a negative power, that is the same thing as that number to a positive power. What a negative exponent means is it means to take whatever fraction you have, and I want to remind you that 3 is a fraction. So if I go 3 to the negative 2, 3 is a fraction. It's actually 3 over 1. Okay? It says to flip it over and then change that exponent to a positive. Okay? So a negative exponent says to flip it over or take its reciprocal and change the exponent to a positive. And then the last rule that I want to cover is if I have a quotient, see I've got a product here, if I have a quotient raised to a power, that is the same thing as raising the numerator to the power and the denominator to the same power. And what we're going to do is we're going to apply those 9 properties to do example problems. Before we do the example problems, I need to tell you what numbers I expect you to be able to do without a calculator for raising things to powers. Okay? So anything to the 0th. So any number to the 0th power. If it's 0 to the 0th, you're going to tell me it's undefined. Any other number, you're going to tell me that it is 1. Any power of 1. Any power of 1 is just 1. Powers of 2 to 2 to the 7th. Okay? So I expect you to know that 2 to the 0th is 1, then 2, 4, 8, 16, 32, 64, and 128. And if you just need to multiply those out. I need you to know what 3 to the 0th, 3 to the 1st, 3 squared, 3 cubed, 3 to the 4th, and 3 to the 5th. Okay? 3 to the 0th is 1, 3, then 9, 27, 81, and 243. If you do not know what 3 to the 5th is, well, think of 3 to the 4th as 3 squared squared. 3 squared is 9. 9 times 9 is 81. That's where I got that one. Then 81 times 3, 240 plus 3 is 243. Powers of 4 you need to know are 4 to the 0th, 4 to the 1st, 4 squared, 4 cubed, and 4 to the 4th. That would be 1, 4, 16, 64, and 256. 256 is 16 squared, and that's going to be one of our memorized squares. Powers of 5, 5 to the 0th, 5 to the 1st, 5 squared, 5 cubed, and 5 to the 4th, which are 1, 5, 25, 125, and 625. 625 is 25 squared, and that's going to be one of our memorized perfect squares. 6, I expect you to know 6 to the 0th, 6 to the 1st, 6 squared, and 6 cubed. That is 1, 6, 36, and then 36 times 6 is 180 plus 36, which is 216. Powers of 7 are 7 to the 0th, 7 to the 1st, 7 squared, and 7 cubed, which are 1, 7, 49, and then if you don't know what the next one is, it's 7 times 40, which is 280, plus 63, which would be 343. Powers of 8 are 8 to the 0, 8 to the 1st, and 8 squared. So I'm going to get 1, 8, and 64. Powers of 9 are 9 to the 0th, 9 to the 1st, and 9 squared, which are 1, 9, and 81. Then I expect you to know all powers of 10. I expect you to know the following perfect squares, in addition to what I've already written down: 11, 12, 13, 14, 15, 16, 20, 25, 30, 40, 50. Basically, anything that has a single-digit number followed by zeros, I expect you to know those perfect squares. Any of them that fall in this realm, when it says to simplify, you are going to give me a numerical answer. Anything that is out of this realm, you're going to be able to use a calculator, or you're going to leave it in exponent form. And you're going to see that on the examples. So I'm going to pause the video, erase the board, and then work through examples, taking in these numbers that I expect you to be able to come up with on your own without a calculator. So my first group of examples deal with all of the product properties, which are these first three properties. Okay, and again, every example is required to be worked out into your notes so that you have them as examples to go back to. First example is 3 squared times 3 to the 7th. 3 squared times 3 to the 7th equals 3 times 2 plus 7. So this would be 3 to the 9th. 5 times 5 to the 9th. There is an invisible 1 there. So I have 5 to the 1st times 5 to the 9th is 5 to the 10th. Negative 7 squared times negative 7. That's a negative 7 to the first. That is negative 7 cubed, which is the same thing as negative 1 cubed times 7 cubed. And 7 cubed was one of our memorized cubes. And that was 49 times 3, which was, 49 times 7. 280 plus 63 is 343. And then negative 1 to an odd power. So let's go. I have negative 1 times negative 1 is a positive 1 times negative 1 is a negative 1. So if you have a negative to an odd power, you have a negative. So this one, because that is a memorized one, you have to actually do the work. I have x squared times x to the sixth. This x is x to the first. 2 plus 1 is 3, plus 6 is 9. Next one, I'm going to be using this property. Something to a power raised to another power, you multiply the exponents. 4 squared to the 7th is 4 to the 2 times 7, or 4 to the 14th. Negative 2 to the 4 times 5 is the 20th. So I'm going to write negative 2 in parentheses, raised to the 20th power. Next one, x cubed to the 6th, 3 times 6 is 18. Here I have m plus 1 squared to the third power. 2 times 3 is 6. Then I'm going to show you something I do not want you to do because it's illegal. This does not mean that 6 goes to the m and the 6 goes to the 1. Notice there are no addition problems on the left-hand side of these equations, or subtraction problems. This does not distribute into there. Okay? You only distribute with multiplication. This is m plus 1 times 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 m plus 1. And you're going to find out that that's going to end up being a 7-termed, what we're going to call a polynomial in the next chapter. So it's not m to the 6th, 1 to the 6th. Make sure you do not do that. Okay, next property that I'm going to use is this one. If I have a product of numbers raised to a power, that means I raise each number in that product to that power. So I have 42 times 12 cubed, which is 42 cubed times 12 cubed. Next one is negative 3n squared. That's negative 1 times 3 times n. So I have negative 1 squared times 3 squared times n squared. These two are memorized squares. Negative 1 times negative 1 is a positive 1, so I'm not going to write it down. 3 times 3 is 9, so that would be 9n squared. Oops, I forgot to square this one. Next one is 9m cubed into the 4th, all squared. So this would be 9 squared. M cubed squared is m to the 6th. N to the 4th squared is n to the 8th. 9 squared is memorized to be 81. M to the 6th, n to the 8th. And the last one, I am going to combine the first property with the third property. I have to do this exponent first. It means I'm going to put it into the one in the parentheses. Remember, a set of parentheses that doesn't have an exponent is a multiplication problem. So the first step, I'm going to write 5 to the 4th. X to the 8th. Then I have 5 to the 1st times 5 to the 4th, which is 5 to the 5th. X to the 8th. And 5 to the 5th was not one of my memorized ones. We only went 5 to the 4th. So I would leave it as 5 to the 5th, x to the 8th. Or if this was a calculator portion of your next test, you would put 5 to the 5th in the calculator and put that number down. So I'm going to pause the video and I'm going to work through more examples of the other properties. So the last examples I'm going to do are going to take into account all of the remaining properties. The first one is 6 to the 11th over 6 to the 5th. 6 to the 11th over 6 to the 5th. I go 11 minus 5 is going to give me 6 to the 6th. Next problem is negative 4 to the 9th over negative 4 squared. That's going to equal negative 4 to the 9 minus 2, which is 7. The next one is 2 to the 4th times 2 cubed over 2 squared. So I'm going to use the first property for the numerator. Then I'm going to use the quotient property. So I have 4 plus 3 is 7, and then 7 minus 2 is 5, which is 2 to the 5th. That's a memorized one. If you don't have it memorized, use your fingers. 2, 4, 8, 16, 32. For the next one, I have 1 over y to the 5th times y to the 8th. Remember, y to the 8th can be the same thing as y to the 8th over 1. Multiplying fractions, that gives me y to the 8th over y to the 5th. And 8 minus 5 is 3. Both of these intermediate steps are not required. Neither of them are required. Next one is a over b squared. That's directly from this property. I'm going to end up with a squared b squared. The next one is negative 5 over y cubed. So that's negative 1 cubed, 5 cubed over y cubed. A negative cubed we learned was a negative. 5 cubed is memorized as 125. And the denominator is y cubed. The next one is 2/3 cubed, which would end up being 2 cubed over 3 cubed. 2 cubed we have memorized as 8. 3 cubed should be memorized as 27. If you do not have these memorized, at least write this step out so I can give you partial credit on a problem. Next problem, I'm going to use the product property as well as the quotient property and a quotient to an exponent. So x squared squared is x to the 4th, because 2 times 2 is 4. Then I get 4 squared, which is 16, y squared. Next example, I have a multiplication problem, but it's a multiplication problem of 2 things in exponents. So I have to do the stuff in the parentheses first by raising them to a power. I get 2 cubed, which is 8, s cubed, over 3 cubed, which is 27, t cubed, times t to the 10th, over 3 squared, which is 9. So what I'm going to do now is I'm going to look at my numbers. Okay, nothing goes into 8 that goes into both 27 and 9, so I'm going to write an 8 on the top. 27 times 9 is 243. On the top, I have just the s cubes. Then I have t to the 10th over t cubed. So 10 minus 3 is 7. And that's the way I would write the final answer. Another way I could have done this problem with the 3's in the bottom is I have 3 cubed times 3 squared is 3 to the 5th, which is our memorized 243. 2/3 to the 0, well, that is any number but 0 to the 0 is 1. Negative 8 to the negative 2 is the same thing as 1 over negative 8 squared. Flip it over, change the sign to a positive. And then negative 8 times negative 8 is a positive 64. 1 over 4 to the negative 3, negative exponent, says flip it over and change the exponent to a positive. And 4 cubed is memorized to be 64. So I have worked out examples using every single one of the properties, and you're going to spend a couple days in class doing the homework with the examples. So your focus right now is to make sure you have notes that cover all of the properties and that you have worked out every example that I did in the video. You'll also have been given a half sheet of paper that has multiple examples that I want you to work at and turn in at the beginning of class when I look at your notes.